Hey class, this is Ryan. I'm just noticing that people are having a little bit of trouble with the assignment. I sort of want to talk about some stuff that's closely related, and specifically that's binomial random variables and how you know when you're dealing with a binomial experiment and with a binomial random variable. So I have a question here. It's example 3 in the book. This is on page 83, and the idea is that they're asking, what is the probability of scoring 60% on a 10-question multiple choice exam if you guess randomly? Now, when you get a question like this, where you've got multiple trials with a particular percentage chance of getting the right answer, you might be in a binomial experiment. So there's a couple things to check. The first is that you have some number of identical trials. Well, in this case, you have 10 trials, and this is the number of questions. Okay. The second way you verify that this is a binomial experiment is 2, the trials are independent. And if you've been following along in the book and been doing all the readings, you should know that independence just means that the guess on one question shouldn't affect the probability of guessing right on the next question. Okay, 3. And so in this case, certainly, from one question to the next, if I, in question 1, if I guess randomly, then it's not going to affect the probability that I guess random, or that of the probability of the outcome on the second example, or the second question. Number 3, there are 2 options, success or failure. Well, in this case, you either guess the answer correctly, so you guess the answer on the question correctly, and this would be a success, or you guess incorrectly. This is a failure. Okay. And 4, the probability of success or failure is fixed from trial to trial. So the probability of success, now again, this is a multiple choice question, so you have one chance in 4 of guessing correctly. So 1 out of 4 probability of a success on any one of the questions you're guessing on, and the probability, put little periods there, of failure is well, there's 3, it's a A to D question, so it's A, B, C, D. One of them's correct, then that means 3 of them are incorrect out of a total of 4 things you could guess. Okay, now where I'm getting each of these is from page 82. Okay, that's the criteria for if you're dealing with a binomial experiment. Now, if you verified that the question you're looking at is a binomial experiment, at that point you can use the probability of the binomial random variable. You know that that you're working with a binomial random variable. So this is a binomial experiment. So we're trying to determine, and you can kind of figure out what you're trying to determine from the question. So we're asking, what's the probability of scoring 60% on a 10-question multiple choice exam? So we're trying to determine what the probability of 6 correct guesses. I should say exactly 6 correct guesses is. Okay, and remember also on page 82, we have the probability of a binomial random variable is given by this formula. The probability of x, where x is equal to your number of successes. This is just equal to n, choose x, p to the power of x, q to the power of n minus x. Okay, where n is equal to the number of trials. So, yeah, number of successes, in our case, this would be 60, because or 6, sorry, x equals 6, because we're trying to see if we get 6 answers correct. The number of trials, n, is going to be equal to 10. P is the probability of success, which we know P equals 1 over 4, or 0.25. And then Q, this is the probability of a failure. Okay, in other words, Q equals 3 over 4, or in other words, 0.75. All right, so let's get back to the question. So we're trying to figure out the probability that we have 60% on the multiple choice exam. So that means that we have to get exactly 6 questions correct. I should specify that this n choose x, this is a very specific function. It's not a fraction. This is on your calculator n c x. So if you want to figure out what this number is, you put in n c x. And so in our case, well, we'll see in a second here what this is going to look like. So we have the probability that x equals 6, and this is equal to 10. Choose 6 because n here is 10, x here is 6, and then in the brackets we have 1 over 4 to the power of 6, 3 over 4 to the power of 10 minus 6, because remember, x goes above the probability of success, and x is equal to 6. That's what we're trying to figure out. And then this is n, which is 10, minus 6. Okay, so remember, this button, this can be computed with the button 10 C 6 on your calculator, and it should be equal to 210. Okay, another way to write this all, 10, choose 6. You can do everything in decimals, so this is 0.25 to the power of 6, and this is 0.75, and I'm just going to compute this number. 10 minus 6 is 4. Okay, so when you work it out, 10 choose 6 is 210. So we're going to put 210 right here. And then when you take 0.25 and raise that to the power of 6, you get 0.00024. And you get then 0.75 to the power of 4 is 0.31641. And in the end, what you get, if you compute, you multiply all these together, you get 0.01593. Okay, and so that's about 2%. Okay, so there is approximately, or another, I guess you could even say 1.5% is maybe, or 1.6 if we're rounding properly. There's approximately a 1.6% chance of scoring 60 on this multiple choice exam. Okay. So I'm hoping that that's going to help you out. You have to kind of sometimes think outside the box with these ones. So it doesn't always have to be things like multiple choice exams. It could, for instance, be like the random variable could be medical records and seeing, the percentage of people who have caught a particular disease, so long as that disease has a particular chance, the same chance for each one of the people being examined. Let's see. Yeah, so like for instance, like one of the examples in the review exercise, if you look on page 85, question 4, you'll notice that they're saying, well, suppose that during the flu season, it's known that 1 out of every 20 people has influenza. If you shake hands with 8 people at the office luncheon, what's the probability that? And then it goes into some detail. You know what? Why don't we? Well, you know what? I'll save this for another video. But for now, this is kind of how you do a binomial random variable. This is how you do a binomial random variable problem, and this is how you determine that you're dealing with a binomial experiment, and that's what lets you use this formula. Okay. For now, thank you very much. Have a good one.